Hi everybody. Today we are going to try to solve a problem live on LeetCode of medium difficulty. So here I have the problems tab open on LeetCode website. So let's go through that and let's pick like this first medium difficulty problem of add two numbers. Okay, let's look at the problem. Not sure why add two numbers would be medium difficulty, but there is something interesting here. Okay, you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. I see. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number zero itself. Yeah, this assumption is interesting because I don't know how it helps us simplify our code, but okay, we'll see about that. I think I understood the problem. Basically, we are given two numbers, but which are stored in a linked list where both numbers are stored in a linked list where each node in the list has single digit, and also they are stored in reverse order. So, for example, in example one, this linked list of 243 actually represents the number 342, and the linked list of 564 represents a number of 465. And they haven't given any assumption about the length of the linked lists being same or different, which means we could have linked lists of different lengths. Let's see if they have any example like that. Oh, looks like they only have one example. Oh, no, two examples, but yeah, this is not of different lengths. Okay, but I think we have to solve for cases where one linked list is longer than the other one. Should be straightforward to address that or account for that, but just pointing that out. And yeah, our algorithm is obviously very simple because we are given in reverse order of the digits in reverse order. We basically, the first digit in each list is the unit place digits, and so we can just add them up, keep track of a carry forward. The next is tens place and so on, and then we can keep on adding carry forward as well and keep on creating nodes of the result list containing the the non-carry forward part of the result. So it's about basically getting some details of the linked list code right and writing clean code. So with that, let's try to jump to the solution. Again, our approach is going to be simple. We will basically iterate to both the given lists, one node by node. And of course, we have to take care of the condition or the case where one list is already exhausted while other list has more nodes. And we have to keep track of carry. While we do that, we'll look into the digit in each list, add them up the digits along with the carry if there was a carry from previous, and we'll create a new node for the result list and we'll keep on constructing the result list. So with that, let's look at the code section here. Looks like they've already given us a linked list node class that we can use in comments, and that is part of the template code on LeetCode for this problem when it is executed. So we can just basically directly use this list node class. One thing in such problems where we are constructing a new linked list to return is that, remember, we have to return the head of the list to the caller, which makes sense, right? That is how they can get the whole list if we return the head. And when we are returning the head, but we are constructing a completely new list, if let's say, for example, we have a result list equal to null, and this is where we will construct the list 708 in this example, then once result list points to 7, we have to kind of save that as the head so that we return that later, because we'll keep on moving the result list or whatever variable we are using forward to construct more nodes. So in such cases, in order to avoid the special case that, okay, hey, when we first create the node, we have to save it. So the special case will be inside some loop where we are constructing the list. What I generally do is I actually use a dummy node and have the next pointer of that to be the head of the result. And then when it's time to return the resultant head, I return the next of the dummy node. So using that trick or that idea, let me show you what I mean. So let's say we do this, and this is a dummy node. Make result point to a dummy node whose next is the head of the result. So given the comment has become too long, I'm going to take it on its own line. Hopefully that made sense. If not, as I write more code, you will know what I mean. Now, the other thing I want to do is I don't want to change what result points to, because ultimately we have to stay there so that the next of that is head, and that's what we'll return. So what I mean is we'll write a bunch of code here, but at the end of it we'll say return result dot next, because like I said, what result points to is a dummy node, but what the next of that dummy node points to is the real head. And so which means I don't want to change the value of the result, so I'm going to make that final. This is a very good practice in Java. If you don't intend to change the value of a specific variable or what that variable points to, then make it final so that you don't accidentally change the value of that variable. Okay, so that's that. Now we need a variable that actually builds this list incrementally and keeps moving forward, and that will initially point to result. So let's do let me just call it current, and that initially starts by pointing to result, the dummy node, and whenever we need to add one more node, we'll add it to current.next. So that is how we'll keep on building the 7, then 0, then 8, and so on. Okay. We need a carry. We need to keep track of a carry forward digit if we have carry. So let's have that variable. Starts with the default value of 0, obviously. And I think that is all we need in the preparation before we write the loop. Now, thinking about the loop, basically, like I said, list 1 and list 2 don't have to be same lengths, but the loop needs to keep on going this until there are more nodes in either of the lists. So we basically will have this to be the condition of the loop, which means if there are more nodes in L1 or there are more nodes in L2, let's keep going. Now the digit in the first list, now remember, either of the lists could actually have become null, which means there are no more nodes. So we need to check whether they are null, and if so, then the digit in that is 0. Otherwise, it is L1.val. I believe the member name is val, so L1.val. So I don't need brackets here, strictly speaking, in this ternary operator, because it's just one simple expression, but I'm going to keep it for readability. Similarly, digit 2 is, if L2 is null, then it's 0, otherwise it's L2.val. And now that we have read digit from both L1 and L2, let's move forward L1 and L2. L1 equal to L1.next, and similarly here L2 equal to L2.next if it is not. Remember, either of them could be null. That's why we need to do the null check. Okay. Now let's compute the result digit. So let's say int result, or result value, actually not digit, because it could be multi-digits. So the result value is we add digit 1 plus digit 2, and we add the carry value. Okay. So or we could just actually, let's call this sum. Okay, just for a smaller name. This is pretty obvious, so I'm not going to explain much on that. Now, from the sum of the two digits and the potential carry value, we need to figure out what the digit is and what the carry is, and that's pretty easy. So let's say int digit equals, or let's call this result digit so we don't confuse ourselves, is some modulo 10 that gives us the digit, and then the carry, the new value of carry is going to be sum divided by 10. And this is probably obvious and most of you know this, but in Java and most programming languages, when you divide integers with each other, it's a truncation operation, which means if sum was 18 and you divide by 10, then you get the answer as 1, not 1.8 doesn't become 2. It is not rounded, it is truncated. So this basically has the desired effect. And so that is that. And now we are ready to basically compute or create a new node in our result list. Remember, we haven't still created a node for 7. We have the value 7 in result digit, but we haven't really created a node. So the node goes in the next of current. So current.next. And remember, current is not null, so we can directly do current.next. And this is where the dummy node trick really helps, because even in the first time, current is not pointing to null. It's pointing to a valid node. New list node, and then you say result digit, and there is a constructor which just takes the value and will assign null to next as a default value. That happens in Java. If you are writing this in a programming language where the default is not the desired value, you should actually explicitly assign it to null. In this case it does, so I'm going to just do that. And of course now we have to move forward current. So yeah, we have moved forward L1 and L2. We computed the digits and we move forward current, and we have computed our new carry value. So that is pretty much the whole loop. Now one more thing we gotta do is, remember, there is one more thing, is that the result itself, the result linked list, could have more nodes than the longer list of the input lists. So for example, if this was instead of 3 and 4 here, if this was 3 and 7 or more, so 3 and 8, 3 and 9, then there will be a carry forward. So which means you need to create one more node even after the loop ends if the carry is not 0. So we could, one way to do it is we could do this. If carry is greater than 0, then you basically say pretty much this current.next equal to new node, and here you will say carry, and then you will say current equal to, I mean, this is not strictly necessary because this is the last time you are allocating a node. So let's get rid of that, and you can even make that a single line if you wanted. I generally like that. If it is a single statement, if I generally do this, and then you could just return result.next. This will work, but what I think is slightly cleaner is to actually do this, or carry is greater than 0. And because the way to think about it is the loop needs to keep on going, which means every one iteration of the loop creates one node in the result linked list. And we need to create nodes in the result linked list as long as there is more nodes in one list or more nodes in second list, or we have carry that we need to go forward. So it automatically will have the desired effect, and then we can avoid. In this particular case, this wasn't a big deal because it turned out to be just a single statement. But in some problems, you will see how this idea is useful, where there are multiple statements for each iteration of the loop, and you don't want to copy that code over in an if condition for just one edge case. It won't always be possible in all problems to use such idea, depends on the problem, but here it is, and so it works out really nicely. And since we have checks of L1 being null and digit 1 is 0 and so on, it automatically works out even if these two are null and just the carry is not 0. This whole thing still works. So yeah, I think I'm ready to run this. Let me just go over it one more time in my head visually before I declare it that it probably works. Maybe there are compilers in Java that I'm not writing in an IDE which auto completes and stuff like that, so It's always possible, but I think I'm ready to run. I have returned the result, and yeah, let's run this. Yeah, it's accepted. Yeah, this created the desired thing. Let's add a test case though, because like I said, oh, it does have this test case, which is nice. Oh, it did have an example 3. I missed that. Anyway, so this is a good test case where there are different number of digits in both the lists, input lists, 1, 2, 3, 4, 5, 6, 7, and 4. And here 1, 2, 3. Oh yeah, so this also covers the case where the output has one more digit than the longer input. So that's good. I think I like that. Okay, cool. I think before we call this done, one thing I would like to add is that in reality, even though they have asked us to assume that each node contains a single digit, given that the data type of the value in a node is int, I generally like to add an error check. So here I would add an error check in production code at least if digit 1 is greater than is less than 0, or basically you also want to check negatives, or digit 1 is greater than 9, or we can do the same for digit 2 in the same if condition. If we want a different error message, of course we can do it in different if conditions, but 2, none of that should be true, and if any of that is true, we basically say throw new. I think one good exception to throw here is illegal argument exception, and it's good to have a detailed message here that the argument is a linked list, but one of the nodes in the linked list has an invalid thing. But here for just this video, I'm just going to say digit in the node is invalid, or the value in the node, not the digit, value in the node is invalid. Okay, in reality I would also want to print the value, or actually append the value that is invalid. So it's good to add such assumption validation code, even though in case there was some bug in constructing that list by the caller, we gracefully fail instead of returning something really random. That's one error check I would add. And I think that is pretty much it, because this also takes care of negatives in int. Okay, hopefully that was helpful. See you next time.